Good morning, Miss Carly.
Good morning.
Good morning, Evan.
Good morning.
Good morning, Will.
What's up?
The sunshine.
Yeah.
Let's see. No Ethan, no Summer, no Ashley. Ethan, Summer, and Ashley. Well, section 5.3, I believe, was easier than what we did in 5.2, just because you're becoming a little bit more familiar with the trigonometric functions. You're getting a little bit more comfortable with the unit circle, and it doesn't have identities in it, although y'all seem to do really well with the identities. Hey, Will, I don't think you sent me the 3 identities that I emailed you yesterday, did you?
I did on the Outlook. I took a picture of it.
Okay, you must have just sent it after I closed my computer last night, so it'll be there this morning. Yep. Okay.
Yeah.
So you've watched the video, and yesterday I mentioned that the big thing in 5.3 is extending the definition of the trigonometric functions beyond the definitions we've already had. Our initial definitions were in terms of ratios of sides of a right triangle, just the opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And then we extended that to trigonometric functions of any angle in the Cartesian coordinate system. You give me a point, I can either drop or raise a vertical line to the nearest x-axis and then use my definitions that I have for opposite, adjacent, hypotenuse. But not only that, I could use the definitions sine is y over r, cosine is x over r, and tangent's y over x. That was for a circle of any radius. And you could always find the radius by the square root of x squared plus y squared. But what I said yesterday was, just to make this easier, let's talk about the trigonometric functions on a unit circle. And what's the definition of a unit circle? What does that mean? There are 2 specifics that make it a unit circle rather than any other circle. Anybody? Give me just one of them. How about read that? A unit circle is a circle of radius 1, and it's centered at the origin. So if this is the unit circle, then any radius you draw is 1, and it's centered at the origin, so that we know the coordinates corresponding to these 4 quadrantal angles. We know this is 1, 0, 0, 1, negative 1, 0, 0, negative 1. And we've practiced dividing that circle up into different degree measures, different radian measures, and labeling the point at on the coterminal side of each angle. All right, so, oh, one other thing. This is just a note that from now on, when we just see sine of a number, sine of 2, we know that's not sine of 2 degrees, or they'd be using a degree symbol. Sine of 2 means the sine of an angle of a measure of 2 radians. Now that's not the same as 2 pi radians. 2 pi radians would be about sine of 6.28. This is just a sine of 2 radians, And that's what we'll assume that any trigonometric expression means if it doesn't have the degree symbol. It's just the sign of that real number. All right, so I do want to say something about formulas for negatives down at the bottom of the notes to make sure you understand that. But what else might you need to see from the 5.3 homework? Or any questions you have from the 5.3 video?
I have a question on
Yes,
number
ma'am.
5.
Number 5.
Could you go over the parts C and D again? I understood A and B, but C
Yeah,
and D confused me.
I can see why that's bothering you. This is page 363, number 5, and all we're given is a point 3/5, and is that -4/5? And then let me just mention A and B. I won't do them, but the A part says if let P of t be the point on the unit circle that corresponds to t radians if P of t has the given rectangular coordinates. So this is my function, or this is my ordered pair P of t. Give the coordinates for P of t plus pi, for P of t minus pi, and then what it sounded like Ashley was asking, P of -t, and that was you, Ashley, wasn't it?
No, it was me, Kelsey.
Kelsey, I'm still working on your two voices. Okay. In what quadrant does the point 3, -4/5 lie? Or 3/5, -4/5? Which quadrant?
Is it 4?
Yeah, because x is positive and y is negative. It's somewhere here. I don't know exactly where. Actually, it'd be way closer to the unit circle because this is, or excuse me, much closer to the origin, but that doesn't really matter. What matters is that I know it's in the 4th quadrant. All right, so what would the point be if you went to this angle? This is a point on the terminal side of an angle, and so we started in standard position, went around to right here on the unit circle, and hold on one. Yeah, it does say unit circle. Went to right here. Where would you end up if you went pi more radians? Pi radians corresponds to how many degrees?
$180.
Okay, so if you started in standard position, went to this point, and then went 180 degrees more, where would you end up? In what quadrant?
2.
Yeah, 180 degrees, keep on going another 180 degrees, you're in the 2nd quadrant, the same point, except for your x will be negative and your y will be positive. And the B part, the A part was t plus pi, so I kept going counterclockwise. The B part is t minus pi, so I'm going to go clockwise. In what quadrant would I end up if I started here and went 180 degrees clockwise?
2.
Yeah, that would also be the 2nd quadrant. When you're going 180 degrees, it doesn't matter which direction you're going. That's another halfway around the circle. Now, I see why these two bother you. Take a wild guess how many degrees that angle might be from just, and I'm not asking for anything specific here, but if I started in standard position and went to that terminal side, take a wild guess how many degrees that might be. It's got to be a little bit more than how many? Well, how many degrees would it be if I stopped on the negative x-axis? or negative y-axis?
270.
270. So this is a little more than 270, but not yet 360. Maybe that's 300. I don't know. So how many radians is this 270 degrees?
3/2 pi.
3/2 pi. It's 1/2, 2/2, 3/2 pi. So maybe this is about, let's see, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. Maybe that's close to 7/4 pi, and I'm just guessing. But the reason I'm guessing is P of negative t means go the same distance, but in the opposite direction. If that was 7/4 pi, and I started in standard position and went 7/4 pi in the other direction, in the negative direction, in what quadrant would I end up? Start right here and count 7/4 pi clockwise. What quadrant is that?
Is it 1?
Yeah. If I go the same distance but the opposite direction, I'm going to be 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. I'd end up in the first quadrant instead of the fourth quadrant. And then both of my coordinates would be positive because I'm in the first quadrant. Did that make sense?
Yes.
Okay. And if in the D part, P of that, but count another, sorry. Start here and then count 180 degrees clockwise from there. What quadrant would you end up in? This is P of t. This is P of negative t. If you started at P of negative t and went 180 degrees clockwise, in what quadrant would you be?
Three.
Yeah, that's 180 degrees is halfway around the circle. It really wouldn't matter if you were going clockwise or counterclockwise. If you go halfway around the circle, you're going to end up at that same point in the third quadrant where the x and the y are both negative. So all four of these parts were about going 180 degrees from some initial point. Some of the parts were going 180 degrees counterclockwise. Some of them were going 180 degrees counterclockwise, but they were all the same distance from standard position, just depending on which direction you were going. Is that okay now?
Yes, I understand it now.
Okay, all right. What else from the homework? Are you getting pretty good at counting by quarter pies and sixth pies so that you can do 9 through 14 quickly? Actually, 9 through 19 quickly.
Kind of.
Okay. The thing I wanted to say about the formulas for negatives, and I've typed this in the notes, do not memorize the formulas for negatives. I want this to make sense to you so you can save your brain space for memorize something that doesn't make sense. I don't know what that is in math, but I don't want to just memorize crap. I'll forget it on the test. So I want to think about why these formulas for negatives are what they are. Sine of negative t is the same, or negative t radians is the same distance as t radians, but just in the opposite direction. If t is in a positive direction, that means counterclockwise. If you go t in a negative direction, that means clockwise. So here's how I figure out formulas of negatives when I need them. If I go t units counterclockwise, and then I go t units clockwise, same distance, but just in the opposite direction. What stays the same about both of these points? Do they have the same x coordinate or do they have the same y coordinate?
Same X.
Yeah. If this is the ordered pair xy, then what is this ordered pair? Same point, but go ahead.
X negative Y.
Yes. So in other words, I can see whether, despite whether I'm going counterclockwise or clockwise, my x stays the same. That means my cosines stay the same, because that's what cosine is, your x coordinate. My y's are opposites of each other, so my sines are opposites of each other. If I go 60 degrees counterclockwise and then 60 degrees clockwise, my x's will be the same, but my y's will be opposites. And that's really all you need to know about the signs for negatives. Does that make sense? I'm going to assume everyone said yes. Let me say, though, on number 18, to find the sine of some particular angle, I don't even think formula for negatives. I just count by half pi's. In the A part, I count by half pi's clockwise until I get to -3/2 pi's and give the y coordinate there. In the B part, I don't think, oh, that's formula for negatives. I realize that 225 is a multiple of 45, so I count by 45 degrees in the clockwise direction, and then see what that point is and give the x coordinate. On number 39 to 46, I should have said in the video, and I believe I did, instead of using the graph, use the unit circle, because we haven't talked about the graph of the trig functions yet. I want you to solve these by squinting or referring to the unit circle and tell me all of the angles in how many revolutions of the unit circle is 0 to 4 pi?
2.
Yeah, that's 2 revolutions of the unit circle. So I want you to go around the unit circle twice and tell me all the angles whose sine is 1. Well, if you were just going around the unit circle once, how many angles would there be where sine is 1?
Maybe 2.
Is sine your x or your y?
Oh,
Which one?
pretty sure. Isn't it your? I feel like it's your y.
Yeah, but I don't want you to rely on your feelings. It's right here. Your sine is a vertical distance. So it's your y. Your cosine's a horizontal distance, so it's your x. And then your tangent's your y over x. So on number 40, that's really saying at what angles on the unit circle is the y value +1? Well, where on the unit circle is the y value +1? You can just tell me which axis.
Y.
On the y-axis, and if y is +1, it's going to be right here. How many radians is that?
It's pi over 2.
Okay, so in one revolution of the unit circle, x would be pi over 2. Pi over 2 checks. If I said put pi over 2 in the place of x and said what's sine of pi over 2, you'd look at your unit circle and say, well, it's the y coordinate right here, and that's 1. And that's the only time in one revolution of the unit circle. But if you went around the unit circle again, what would be this angle when you go around the circuit second time?
Would it just be 1?
That's what y would be, but I'm asking for the radian measure of this angle.
Or is it just, or did it be pi?
No. If it's pi over 2, let's see, I don't want to write on that, but let me grab another piece of paper. This is pi over 2 where the ordered pair is 0, 1. So in the equation, sine of x equals 1, then I'm looking for the angle where sine is 1. And in one revolution of the unit circle, that angle is pi over 2. But if I have to go all the way around the circle and land here again, I'm finding a coterminal angle. How do I find an angle that's coterminal, ends at the same place as pi over 2? Anybody? How do you find a coterminal angle? How many radians will get you all the way around the circle again? How many radians are in a circle?
2
2
pi.
pi. So one of the first things we did in 5.1 was I gave you an angle and I said find coterminal angles. You just added multiples of 2 pi, or you could subtract multiples of 2 pi. So first time around the circle, the name of this guy is pi over 2. But the second time around the circle, add another 2 pi to that, and its name is 5/2 pi. So pi over 2 and 5/2 pi would be the two angles in two revolutions of the unit circle where the y coordinate is 1. Now, another thing you could have done, if you didn't want to add 2 pi, add fractions in your head, you could have said 1/2, 2/2, 3/2, 4/2, 5/2. I'll be back where I started. So those are the two angles in two revolutions of the unit circle where sine is 1. Is that okay, Will?
Yeah.
All right. In 42, I'm looking for an angle whose sine is, well, forget the negative for a second. What angles, multiples of what angles have y being square root of 2 over 2? Are those my multiples of pi over 4 or my multiples of pi over 6?
Oh, those are pi over 4.
Yeah, my pi over 4s have both the x and the y being square root of 2 over 2, except for positive or negative, depending on what quadrant you're in. So what two quadrants would have angles where sine, or your y coordinate, is negative?
Quadrant 3 and 4.
Okay, so I want the third and fourth quadrant multiples of pi over 4. That's the two angles I'm looking for. First time around the circle, this one is 1/4, 2/4, 3/4, 4/4, 5/4 pi. And this one is 6/4, 7/4 pi. So in one revolution of the unit circle, that would be your two solutions. But if you have to go around the unit circle again, you could add 2 pi to this one and add 2 pi to that one. Or you could just keep counting by quarter pies. This is 8/4, 9/4, 10/4, 11/4, 12/4. This would be 13/4 the second time around. This would be 14/4. That would be 15/4. So in 2 revolutions of the unit circle, you would have 4 angles where sine is negative square root of 2 over 2. All right, there's a specific reason that I want to mention. Let's see, I'm not sure if it happens on number 50 or not, but notice the directions are different for 47 through 50. It's still 2 revolutions of the unit circle, but for some crazy reason, they're giving you starting with negative pi over 2 to 3/2 pi. That means if I come up with negative, or let's say if I come up with 7/4 pi, 7/4 is not a number between these 2 values. So I have to make sure that my answers are between negative pi over 2 and 3/2 pi. Let me show you how I think about that. Number 50 says, I want all the angles where tangent is -1 over square root of 3. And my answer has to be between negative pi over 2 and 3/2 pi. So instead of calling the negative x-axis, or excuse me, negative y-axis 3/2 pi like I normally do, I could call it negative pi over 2. Just go pi over 2 radians clockwise. And if I go around the circle again, 3/2 pi is coterminal with negative pi over 2. I just have to make sure I give the angles as values between these 2 numbers. Now, which angles have square roots of 3 in them? Multiples of pi over 6 or multiple of pi over 4?
Can you say that again?
I feel like I need to. Which angles have coordinates that have a square root of 3 in them? Are they the multiples of 30 degrees or the multiples of 60 degrees? Oh, I'm sorry, multiples of 30 degrees or multiples of 45 degrees?
It would be the 30 degrees.
Right. The 45s all have square root of 2 over 2. The 30 degrees have square root of 3 over 2. Now, 30 degrees is how many radians? Because we're given our answers in radians here, not degrees. Pi over 3. It's 1/3 of the way to pi over 2. What's the radian measure of that angle right there?
Oh, you're talking just like straight up degrees, or?
No, I want radians. We know it's 30 degrees. You already told me it's 30 degrees, but how many radians is that?
Pi over 3?
30 degrees is pi over 6. This is 1/6. This is 2/6. This is pi over 3 right here, and then that's 3/6. So 1/6, 2/6, 3/6. All right. Here's what I figured out so far. I figured it out. Excuse me. I figured it out. I said the same thing again. I figured out that this is a multiple. The answer is going to be a multiple of pi over 6. What quadrants could I have angles whose tangent are negative? Where is tangent negative? And anybody jump in and help us with this?
2 or 4.
Yes, when I have a, what's the word I'm looking for? When I have X is negative and Y is positive, or when I have X is positive, Y is negative. So in one revolution of the unit circle, I expect to have 2 angles whose tangent is negative, and one of them is going to be in the second quadrant, one of them is going to be in the fourth quadrant. Instead of or, I'm going to say and, because I want to get both of them. The only other thing I have to figure out, I'm almost through here, but I need to figure out is the angle whose tangent this, the one that's close to the x-axis or the one that's close to the y-axis? This pi over 6, what's the ordered pair at pi over 6?
Square root of 3 over 2 and then 1/2.
Did you have to look at your circle, or could you squint and say, right here, the x is close to 1, so the x is square root of 3 over 2 and the y is 1/2? Are you about to get that without having to flip back to your unit circle?
Yes.
Okay, good. That's something everybody needs to work toward. I heard papers flipping. I didn't know who was flipping papers, but you shouldn't have to be referring back to your unit circle. You're not going to get that unit circle tattooed on your arm for calculus because you can't figure this out. You need to practice figuring it out. At pi over 3, it's your y is almost 1 and your x is 1/2. So what's the definition of tangent using x's and y's? Is it y over x or x over y?
Y over x.
All right, so which one of these 2 ordered pairs, if I took the y and divided it by x, notice dividing by a fraction is the same as multiplying by the reciprocal. So is it square root of 3 over 2 times 2 over 1, or is it 1/2 times 2 over square root of 3? That would give you the square root of 3 in the denominator. If you divided the y by the x, would it be here at pi over 6 or at pi over 3 that your square root of 3 would end up in the denominator? At pi over 3, if I took the y and multiplied it by the reciprocal of the x, the 2's would cancel, and where would the square root of 3 end up? Top or bottom? Is that what we're looking for? No. What about this one? The y divided by the x or multiplied by the reciprocal of the x. That's the one that ends up with square root of 3 in the denominator. Now, this whole problem has taken a lot of thought, and I've tried to carefully say what all my thoughts were. I didn't write them all down, but the first thing I established was that where tangent is negative, that's going to be a second and a fourth quadrant angle. The second thing I determined was if it's a square root of 3, it's going to have to be a multiple of pi over 6 or pi over 3, not a multiple of pi over 4. And then I'm just trying to decide, okay, which one will it be? Near the x-axis or near the y-axis? Near the y-axis, my square root of 3 would end up in the numerator. Near the x-axis, my square root of 3 would end up in the denominator. So I'm almost through. I just want the second and fourth quadrant angles that are close to the x-axis. In other words, I want the name of this one, and I want the name of this one. What's the name of this one near the x-axis?
That one's just going to be negative square root of, negative square root of 3 over 2. If it's close to the x-axis.
I'm asking for the radian measure.
Oh, yeah. So the 5 pi over 6?
16263645656. That's exactly right. We finally found one of the answers.
And
5, 6.
the other one is just 11 pi over 6.
All right. 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6. So in one revolution of the unit circle, there are 2 angles that have a tangent of this. Now, if we go around the unit circle again, or let me say one thing before that. Is 5, 6 pi between negative pi over 2 and 3/2 pi? This is, yeah. 5, 6, this is negative, what am I trying to say? This is negative 3, 6, and this is 9, 6. Is 5, 6 between negative 3 and 9?
Yeah.
Yeah. Is 11, 6 between negative 3, 6 and 9, 6?
Mm-hmm.
No, it's not. 11's not between negative 3 and 9. Now, we've established that there is this angle whose tangent is negative 1 over square root of 3. I just can't call it 11, 6 because 11, 6 is not between these two numbers. What other name could I give this angle other than 11, 6 pi that would be between these two numbers? What's another name for that angle? What's a name for it as a negative angle? I could name it negative what? How many radians clockwise is it? Anybody? (11.6) radians counterclockwise is the same as 1/6 radian clockwise. That's also known as negative pi over 6. Go 11/6 pi in this direction or just 1/6 pi in this direction, you end up at the same place. So instead of giving 11/6 pi as an answer, I need to give its coterminal angle negative pi over 6 as an answer. And actually, I said something wrong a minute ago. I said this is still 2 revolutions of the unit circle. It's not, because if this is negative pi over 2, that's 0, pi over 2, wait, negative pi over 2, 0, 1/2, 2/2, 3/2. 3/2 pi is just in 1 revolution of the unit circle. Now, I spent a lot of time talking through that one. And honestly, I could do that problem much more quickly if I weren't talking, because I'm familiar with the unit circle. I could immediately figure out that I want to give two answers. One of them's in the second quadrant, one of them's in the fourth quadrant, and I could figure out pretty quickly if it's the angle near the x-axis or the angle near the y-axis that gives me square root of 3 in the denominator. Based on the quietness I experienced while I was asking questions there, I don't know if y'all are just sleepy or shy or whatever, but it sounds like you're not totally comfortable with the unit circle yet. You don't quite have memorized and practiced everything that you need to memorize and practice. So I was going to tell you, how much time do we have left? We have about 10 minutes if we need it. What I would do this weekend to get much more comfortable with the unit circle, because you absolutely must. I can't tell you in calculus, you cannot sit all day to try to figure out the angle whose tangent is -1 over square root of 3. You have to be able to figure that out pretty quickly in calculus. And your calculator won't give you an exact answer. What decimal is this close to? If there was a way to punch this on the calculator and get a decimal approximation of that, what would it be close to?
Oh, which one? My screen went black for like 10 seconds.
Okay, -pi over 6. As a decimal, what is that close to?
That would be close to the origin.
Close to what?
Would it be close to, hold on one second. I need to do this.
I'm just saying, give me a number that this is close to. I'm not asking any kind of trig thing. I'm asking what?
Be like close to 0 or 1. Like one of those numbers.
What's pi close to?
3.
What's -3/6 close to?
0.5.
Yeah. So if there was a way to punch this on the calculator, and there actually is, and we'll talk about it later, but if I did punch that on the calculator, my calculator could give me about -0.5. It couldn't give me -pi over 6. If I want an exact answer, this is how I'm going to figure it out, because my calculator can't give me an exact answer for that. I could check my answer. I could say the answer is -pi over 6. And then when I learn how to use a calculator to find the answer here, it better be close to -0.5. Oh, you came back. Okay. So what I was saying a minute ago is either y'all are sleepy or quiet or not quite as comfortable with the unit circle as you need to be. And that makes sense. You've only been looking at it a week. But things that you can do this weekend to help are print and fill out several copies of the unit circle. And I gave you a nice unit circle in the section 5.3 notes, a blank one. You just print out more of those, or you can print out infinitely many of them on the internet. You can practice, actually, I'd have to think just a minute about how to make this show up on my calculator right now, or excuse me, on camera. Right now, my screen is only showing what is under this camera that I have. I'm afraid I'd have to think too hard to show you a website right this minute, so I'm not going to try to do that. But I'm going to say practice trig link in Momentum. I told you about that yesterday. There's a link to a website you click on. It will either give you degrees and you instantly type in the radians, or it'll give you radians and you instantly type in the degrees, or You can set it, there are all different kinds of settings. You can set it to ask you for the ordered pair. You can set it to ask you for the sine or the cosine. It's a very, very good practice. Practice is the only thing that makes you quick at identifying the kinds of things I was asking in number 50. Practice that. And then 2 extra practice worksheets in Momentum are simplifying trig expressions, because that's brand new and still kind of difficult, but we do it a whole lot in calculus. And then there's another extra practice verifying trig identities. So I'm not suggesting that you spend all weekend on trig, but spend some time this weekend getting more comfortable with everything that's brand new to us in chapter 5. And then watch the 5.4. We have 2 days for 5.4. No, we just have 1 day for 5.4. So you need to watch the 5.4 video and try homework. And I'm starting to feel guilty here if I write down anything else, but they're suggestions. They're not all requirements. This is a requirement. And the last requirement is MyMathLab 5.3 homework. And it's not in there yet, but I'll find 6 problems like these problems in 5.3, and that'll be due at 9 o'clock. Actually, these 2 things are due at 9 o'clock Monday. These other things are just extra practice you can do to get more comfortable with what we're doing. All right. We probably have about 5 more minutes. Does anybody have any other question from 5.3 homework? I believe we've talked about all the different kinds of problems that are there. All right, does anybody have anything else to say? Questions to ask before Monday? Is anybody still there?
Yeah.
Yes.
All right, I heard 3 sweet voices. That means 2 people are quiet. We lost Miss Ashley somewhere along the way. Y'all have a good weekend. Be safe. Be away from everybody. Just go outside and play in the yard.
I
All
have
right.
to work. I have to work. It's not possible.
No, you don't work 48 hours this weekend.
No, actually, no, not 48 hours, of course, but that'd be pretty dope.
Yeah, go outside and get some fresh air. It'll be good for you. All right, y'all have a great weekend.
You too.
Bye-bye.
You too.